Next, we will study the concept of confidence interval. So, in the previous lecture, we have seen how to find the probabilities using the Z values. Now, we are moving to the concept of confidence interval. So, let us take the earlier example itself. That means it is producing with a light bulb with a average life of 1000 hours and standard deviation of 100 hours. Okay, so that means all the light bulbs have a variation in this in years, number of hours it will last. So that means you can ask the question, what is the confidence that a bulb lasts between these many hours? So for example here, so you will get, so you can say here, let it be values, and this is 90%. We have seen the probabilities. So 90% of bulb will last between these two values, Z1 and Z2. Okay, so it can be, for example, 900 and 1100, right? So we can find that. How to find it? How to build the confidence interval? So this is the 90, with the 90% confidence, you can say that the light bulbs will have a life between, so between Z1 and Z2, X1 and X2. Let us call it X1 and X2. How will you find X1 and X2? So for that, again, you will use the concept here, that is the probability. So you can say, so this is 90% means this will be 0.45 and this will be 0.45. Okay, and so this area will be 0.05. So the corresponding to this Z value is, so corresponding to this probability, you can see it will be 0.45 plus 0.45 plus 0.05, all this area to this side. Okay, so this will be 0.95. So you can use the Z table, so that corresponds to this area, full area. So 0.95, let us search here in the Z table. It is, so let us look at the probabilities here. You can see the, here you can see it is 0.95, it is close. So 0.9495 and 0.95, so it will be 1.6, it will be 1.645. let us take it as 1.645, right? So this is the Z value. Okay, that means we were drawing here and we located a 1.645, and this side you can see this area we have found it to be 0.05. Let us find that also. So keep this in mind, 1.645. So corresponding to 0.05 also. Okay, so here it is minus 3.29. so we got minus 3.29 and 1.645. sorry, it is 0.05. So it will be, it is 0.0005. It is 0.05. You need to search for 0.05. It is corresponds to minus 1.64. Okay, it is minus 1.64. It is here. So Z is minus 1.645 and also the positive value is 1.645. So Z lies between minus 6.45 and 1.645. Okay, so we were drawing the Z table. So here it is 1.645 and it is minus 1.645. So here between these you have all the 90% of the values. Okay, so our mean was 1000 hours, standard deviation was 100 hours. So you can see here 1.645 is equal to x minus 1000 divided by 100. So x is equal to 1000 plus 164.5, 1164.5. And similarly this x2 also, it will be 1000 minus 164.5. So you will get the value. So this is how you build the confidence interval. Okay, so all the 90% of the bulb will have a life between 1164.5 and 835.5. Okay, so this is how you find the confidence. So with confidence you can say, with 90% confidence you can say that the life of bulb is between 835.5 and 1164.5. Now let us look at a problem here. So the problem is, a sample of 20 students has an average test score of 76 with a sample standard deviation of 8. Assume the test scores are approximately normally distributed. So calculate a 95% confidence interval for the population mean test score. So that means here you have a normal distribution with average test score of 76 and standard deviation of 8. So you need to fit in a 95% confidence interval. So this will be 95%. Okay, so this here we can find the Z. First find the Z corresponding to, what's the probability? You need to take all the probability to this side. So that will be here, this side will be 0.475 and this side is 0.5 because this is symmetrically distributed. So first we will find Z, probability of Z corresponding to 0.975. Okay. So again we will search here. So 0.975. Okay. So from the table you can see here, it is here, it is 0.975. So that is equal to 1.9, 1.96. Okay, so it is, so is it here 1.96. So by symmetry, this will be minus 1.96 here. Okay, so we got the Z score, and Z is equal to x minus mu by sigma. So you can substitute here and get x is equal to 1.96 into 8 plus 76. So this is equal to 91.68, and so this corresponds to 91.68, and so the other value is 60.32. So with 95% confidence, you can say that the scores lies between 60.32 and 91.68. So this is how you find the confidence interval.